Hey Chemistry, Mrs. KJ here, going over 5.04, Types of Heat Transfer, Part 2. So, we were watching the Eureka video about convection, and we had just gotten to the point where they were going to put something that's less dense than water, such as a cork, inside a beaker of water. The buoyant force is pushing the cork back up. So what buoyant force means is the fact that, you know how when you've ever dove into water and if you just let your body relax, how you just naturally seem to rise up? Well, gravity, of course, should take you where? Back down. But if you lay your body out flat, so you take up lots of area, and you just relax, you'll float up to the top. Obviously, some people float better than others, depending on how comfortable you are in water and your percent composition of muscle and fat. Either way, the pushing up is because of the water molecules in here have a force called buoyancy, and they push it back up. So if something is less dense than water, even though gravity is pulling it down, the buoyancy force is bigger, so it obviously pushes the cork up to the top. When water is heated, its molecules speed up and expand, and then they become less dense. And the less dense water floats, but then it starts to cool off and it goes back down, just like the hot water system in your house. And that's why it's in the basement. But the house next door doesn't have a hot water system. It's heated by hot air instead. Their furnace is also in the basement. Why? Because the principle of buoyancy applies as much to gases as it does to liquid. When air is heated, the molecules speed up and they expand, and therefore they become less dense. So hot air rises just like hot water rises. That's how hot air balloons work. When the air inside the balloon is heated up, it expands. And therefore, there's not enough room for all the hot air in here. So some of the hot air actually escapes. So there's fewer air molecules in the hot air balloon than there was before. And now it's really less dense than it was compared to before and compared to the molecules outside. So now the hot air balloon is less dense and it floats. Hot air rises also comes into place when you are heating something to cook, right? If you put the hot dog under, it's not going to cook. If you put it right above, obviously it's going to cook a lot faster. And this is why your neighbor's hot air heating system works on the same principle as if you heat your house through hot water and radiators and a boiling system. So if you use something else where it's hot air, again, the air goes up, the cool air goes down. You have what's called a cold air exchange. If you don't know where that is in your house, go ahead and ask your parent or guardian. And you have a cold air exchange, and that helps move the air around your house. Hot air goes up, cools, and the cold air goes back down. Since the behavior of gases and liquids is so similar in this and many other respects, and since they can both flow, scientists call both of them fluids. So fluids are liquids and gases. So hot is going to rise, cold air is going to sink. Hot liquid's going to rise, the colder liquid's going to sink, and we call that convection. And it's thanks to convection that balloons go up, and hot dogs get hot when you put them over the fire, and the furnace in your basement is enough to heat your whole house. All right. So again, these are kind of cute little videos if you ever want to watch them. They have nice little sound effects that I'm not going to do for you. And now we can go on to our third type of heat transfer. So we already did conduction and convection. Our third type of heat transfer is radiation. It's the transfer of heat in the form of waves through a substance or through a vacuum. Now, not vacuum cleaner, but vacuum meaning there are no particles, like in outer space. There's no air out here. There's basically nothingness. And this is the only way the sun's heat can reach the earth. Because in conduction and convection, they have to involve the atoms, the particles next to the heated ones, in order for the heat to travel down the rod, or in this case, the heat rose and the cold came back down. Well, the radiation, the heat needs to travel through space, and it's able to do that because it doesn't have to hit other atoms and particles. It can, but it doesn't have to. And radiation can be from other sources besides the sun. So I like this example. Radiation, if you're sitting next to a fire, you're going to feel the heat radiating out to you. Conduction, if you stick the poker in there and hang on to it too long, obviously you'll burn your hands. Or convection, when you turn on the fan, then all the warm air was up next to the ceiling, and depending which way your fan blades are tilted and which way you spin it, it can help bring that warm air back down. Here's another example. Radiation, it radiates out in all the directions. Convection, heat rises. Okay, so I like this because it really says, oh yeah, off to the side I'm getting more radiation. Convection is the fact that it's rising. And then of course conduction, holding the poker. Radiation is going out in all directions. In this case, there is convection from the fire and the air above it, but there's also convection in the hot water. And conduction would be the handle. And then there's a Venn diagram. So kinetic energy, ways to transfer thermal energy, is true for all of them. Conduction, through direct contact between particles. So warmer, bumps in, towards the colder end until it's all the same temperature. The more dense, the faster energy travels. And of course, we talked about metals, how metals have free range electrons and they bounce all over the place, like if you play a pinball machine, and they help heat up the metal a lot faster. Convection, heat rises because it's less dense. Cool air or cool liquid, so cool fluids are more dense, so they sink. Again, it's fluids, so liquids and gases, and it causes our weather. And radiation moves through electromagnetic waves through empty space. It can, of course, move different places on Earth, like when you have a fire. But the #1 example for radiation is the sun. And so now let's go ahead and look at the Eureka video of radiation. So radiation waves. If you touch something that's very hot, you'll get burnt. That's because of conduction. The heat is conducted by a sort of domino effect from molecule to molecule or from atom to atom. So it goes from the hot object into your finger. That's the first way, conduction. But if you hold your other hand above it, you'll also get burnt. That's because of convection. The hot object causes the molecules of air above it to speed up. The hot air expands and it becomes less dense, and therefore it goes upward. And that's our second type, which is convection. And they're not the only two ways that heat can be transferred. There's another one, and that's the one that we just talked about, which was radiation. It can't work through conduction because you're not touching it. It can't be convection because most of the space between you and the sun is just that, outer space, except for, of course, the atmosphere around the Earth. It can't be convection. So that's how we know there had to be a third form. Because there's nothing out in outer space to do the convection, but the sun still feels hot. So then we go into how is that possible? The third way, of course, is radiation. So we need to remember that heat is, in fact, remember, is energy. There's different types of energies like light and sound, but again, we're just talking right now about heat. Energy can travel in a bunch of different ways, and one of the main ways that it travels is through waves. Kind of like if you look in the ocean, the waves there, or that the boat causes, or if you drop a pebble into some water, or the waves that travel along a rope, like if you bring it up and down. In all these cases, what you're seeing is the effect of the movement of the energy itself by ways of waves. Now, you can make this umbrella move without directly touching it. So, what do you think he's going to do? Well, he makes a wave And what he's doing is he's making the energy travel through the space between the person and the umbrella, and it's making the umbrella move. The heat energy from the sun travels like that. And it sends out those waves in all directions, kind of like the spoke of a wheel, which is what they call it, except in Latin, which is radius. And so that's how they get the word radiation, which is our third type of heat transfer. So it's by means of radiation waves that the sun can transfer its heat energy to you and make your molecules go faster and therefore make you hotter. It's kind of cool, isn't it? Even though the sun is millions of miles away. Just by the means of waves, you can make the umbrella move, and the same thing's happening. The sun is making your molecules move faster because it's giving you the heat energy because it's radiating. Just like a fire, it radiates in all directions. Or a stove. Or an electric light bulb. They radiate the heat energy in all directions. Whereas convection, remember, has to do with it rising. But radiation, even you, when you're hot, you give off waves of energy too. So waves are all over and radiation goes in all directions. All right. So for this, obviously you need to know your 3 ways that heat can transfer. Go ahead and do the pre-quiz and check your answers. When you're done with that, go ahead and take the quiz.